Very good morning to everyone. In this lecture, EC 8791 Embedded and Real Time System, Department of Electronics and Communication Engineering. Today, we are going to discuss the Unit 5 Process and Operating System in Embedded System Design. In previous lectures, we are discussed already. We are discussed the introduction of embedded system and also the what are the processor and the peripherals we are using the embedded system design, and how do the program we are optimize the energy and power level consumption, and how do the real time operating system structure. Now today in this session, the process and operating system, how to the entire process, that is multiple processing in the real time operating system, and how to the schedule we are processed, how to we are scheduling the output, executed output, and how to evaluating the performance or power and real time embedded system design. Now this is a syllabus of unit 5 process and operating system. So the introduction: the simple application can be programmed on a microprocessor by writing a single piece of code, but for a complex application, the multiple operations must be performed at widely varying the time. So the two fundamental abstractions that allows us to build complex applications on microprocessor, that is a process. It defines the rate of rate. It defines the state of an execution program, and the operating system, that is OS. It provides the mechanism for switching the execution between the process. Now we can move the multitask and multiple process. The system which are capable of performing the multi-process, it is known as a multiple processor system. The multi-process system can execute multiple processes simultaneously with the help of the multiple CPU. So the multitasking, it is the ability of operating system to hold the multiple process in memory and switch the processor for executing one process. So these are the multitask. So the tasking and the process. The task is nothing but the different part of functionality in a single system. For example, mobile phone, cellular phone. When the design a telephone answering machine, we have defined recording a phone call, answering a call, and operating on the user control panel as distinct task at a different rate. For each application in a system is called a tasking. Now, what is the process? Tasking and the process. See, the process is a single execution of program. If we run the same program two different time, we have create two different process. Each process has its own state that include the not only its register but all of its memory. In some operating system, the memory management unit is used to keep each process in a separate address space. In other words, it is particularly lightweight real-time operating system. The process run in the same address space, and it process that share the same address space for often it's called a thread. Now we can see this device is connected to serial port on both end. The input to the box is an uncompressed stream of byte. It is an example for compressed data being sent to the modern systems. It's a real-time modern system. The box emits a compressed string of bits based on a compression table. So the program need to receive and send the data at a different rate. For example, the program may emit 2 bit for first byte and then 7 bit for second byte. You'll absolutely find it's reflected in the structure of the code. We if we spend too much time in packing and emitting the output characteristics, we make drop of the input character. Now, what is a asynchronous input? Example, a control panel on a machine, it provide a different type of rate. The control panel of the compression box include a compression model button that disable or enable the compression so that the input text is passed through the unchanged when compression is disabled. So here the sampling the button state too slowly, the machine will miss the button dispersion entirely. So the sampling it is too frequently, the machine will do incorrect compression data. So to solve the program problem, every in time compression loop is executed. So this is a multitasking and multiprocessing operation of embedded system design. So in this lecture we are discussed the introduction of operating system, processing and operating system in multitask and multiprocessing system. In upcoming classes we are discuss the multi-rate system and how to predict the real-time task. It is a specific system, real-time embedded systems. Thank you for watching this video.